Hello and welcome to episode 228 of Quarkus Insights. Today we're going to be talking about A2A and how it can help break down AI silos. And we've got special guests, Stefano and Kabir. So welcome everybody. Before we start, I guess we should think about whether we have any news. I don't think we do we? Other than
3.30.1 came out last week, but releases are a pretty non-event around here.
Yeah, it's another week, another release. And I don't think there's anything else apart from that. So we can jump right into to talking with our guests. So before we start, maybe do you want to introduce yourselves? Maybe starting with Stefano. So sort of, how are you involved with A2A and how are you involved with Quarkus and what's your background?
Yeah. My background is on Java and enterprise middleware. I'm a manager now on EAP product, on IBM and Red Hat product. And involved in A2A since the beginning. So a quick introduction of A2A, and then we will return to that. Basically, end of April, Google announced this new protocol, and they announced it also then in their conference. But immediately after, I think 2 weeks later, they decided to donate it to the Linux Foundation, which took like 2 weeks, so beginning of June, more or less, they moved to Linux Foundation, but Kabir, I, and the team is working on A2A and specifically Java SDK and test compatibility kit since the beginning, even before Linux Foundation. We started to collaborate with Google Groups after 2 weeks, mid-May, more or less. So we are working on that since the very beginning, both on the specification side, contributing with our feedback and ideas, and of course, implementing the SDK and the TCK. That's it. And then to you, Kabir.
Okay, so yeah, my name's Kabir. I joined JBoss back in 2004, and I've been working on the JBoss/Wildfly/JBoss EAP application server mostly since then. Done a few bits on Quarkus here and there. I also kind of lead the integration of microprofile specs, which come from SmallRye. They're quite kind of heavily tied to Quarkus, so I've been working on that. And then, like last spring, we started working on some proof of concepts and stuff in the AI space. And then since then on A2A.
Nice. So I guess probably some people watching will have heard of A2A, but not everyone will have. So maybe we can, Stefano sort of gave a bit of an introduction, but maybe we could give a bit more about what it is and why people might be interested.
Happy to introduce it. So I have a few slides that can help me. I will not go through all of them. There is a talk by me on Devox Belgium about that using this slide, and you can find it online on YouTube if you want the full presentation. But let me use a few slides just to introduce. This one is new, is not part of the Belgium talk, because it's been pretty impressive to me. A few weeks ago, 2 or 3 weeks ago, CNCF released their usual quarterly report, and somehow pretty surprising for many, quite frankly not for me, but A2A is the most appreciated protocol in agent communication on AI for the people who CNCF asked, so basically the cloud native people, which bring back us to Quarkus and why we are here somehow. So part of that, in general, A2A protocol had a
Stefano,
great.
can you bring the slides into presentation mode so that they're better?
Sure.
Thank you.
Is it any better? Okay. So basically this one is the start history of model context protocol and A2A. The red line is A2A. And pretty surprisingly, also blue line is model context protocol in sense of the specification. The yellow one is the Python SDK, which I put there to don't say too much difference between the two protocol. MCP is for sure popular, but if you look at this, it's interesting because it's more popular as an implementation than as a specification by itself. Then very quickly, what is A2A? A2A stands for agent-to-agent communication or agent-to-agent protocol, and it differs from MCP and complete MCP, not compete. The idea is to have a single agent that is basically built with AI and piece of software using AI and using tools. And for tools, you have MCP that make it everything much easier to integrate tools in your AI. But when it comes to communicate between different agents, specifically a remote agent, here is where A2A get in place. So in a nutshell, it's a protocol defining how to make two different agents in two different places, possibly remotely in sense of network host or whatever, to communicate between them. And it is completely agnostic on the framework used to develop the agent, but also the language or even the operating system or cloud native versus on-premise, and everything is just a communication protocol between the two agents. And so my example that I always use to explain people very easily what is the difference between tools, and so why MCP exists, and what is agent, and so why A2A exists. So I start from a branch. A branch is a tool, indeed, and if you give me a wrench, probably I can use it to repair my bicycle. Probably, if you give me good instruction, because I'm not the kind of guy very good on this kind of things, but I can try at least.
Depends what's wrong with the bicycle.
Yeah, exactly. But for sure, if something is going wrong in my bathroom, I cannot use the wrench. It's a tool that is designed for that, but I'm not able at all to use it. Why? Because I miss skills, skills that is needed to use this tool to make to get to some result or to get to some goal. So and this is the example for me why agents are different from tools. The plumber is the agent which use the same tool, or maybe has more tools. In this example, has much more tools than me, and more important, he has the skills to use them. And I always say that you need to pay a lot of attention also to don't try to use an agent as a tool or vice versa, because it's not designed to be used like that.
That is a fantastic illustration.
And so that's the big difference, you know. When you have a tool, it's designed to be used as a tool, so it's deterministic, it's time boxed, and so on. And instead, the agent has different design. Is multi-turn normally, is unbounded, has unbounded interaction. I mean, normally is stateful, while typical tools are stateless. And and as the classical design to perceive, plan, act, and reflect. So is able to do something in a loop until it got to a goal. And so where A2A comes into place here, okay, this is an article more formal saying basically the same things I told you. And yes, A2A is to make different agents collaborate and have a language to collaborate to get a more complex goal. So it's not just a plumber. In this case, we are building a full house. Very quickly, the core actors, there is a user, and the user can be another agent or a human. There is a client agent, so the agent that starts the conversation, and a remote agent for communication. In our slang, client and remote agent are both agent, but one is called the A2A server and the other one is called A2A client. So the very basic here, there is many agents communicating between them, and they can communicate in two-way in a very standard and synchronous way. So sending a request through the message and receiving an answer through another message. And or they can be long running. And one of the most important part of the specification is the state machine defined for agent, because the agent in A2A are designed for very long running tasks. And when I say very long running, I mean weeks, not seconds. So you start a job, a task, we call it a task in A2A, and this task can take, again, weeks to complete, and can communicate to the client agent through events, like SSE, for example, web SSE, or can also just use a callback, because again, it is very, very long running, but the agent need to keep track of everything is happening. And so the main part that Kabir will show you in the code from Java SDK in a few minutes, we have the agent card. Agent card is basically this. Agent card is how to define what an agent is able to do. So a few things to notice in this agent card that probably help a bit who is a newbie on the technology to understand some core concepts. First, there is a name and a description. And as you can see, those name and description are natural language. Why? Because the client is expected to be an AI, again, another agent using AI. So how to select which agent to delegate part of the work through to natural language. And for this reason, I like to make notice documentation URL, which many people, when say this, put a documentation which is a user documentation, but is not the idea of the specification. There you should put agent.md, for example. So a markdown for another AI explaining how to use this agent. Because again, is supposed to have communication between agents potentially unattended. And then there is a set of capabilities. What are capabilities? Capabilities is what defined by the specification. So for example, being able to stream, being able to push a notification and things like that. And then there is skills. And the skills are completely different. Skills are not defined strictly by the specification, but is what the agent is able to do. And the combination between name, description, documentation potentially, and the set of skills is what the client used to decide what to delegate to a specific agent. So in this case, This is an agent that is able to write, and write what? Has different skill, write content using an outline, or write a short upbeat and encouraging Twitter, blah, 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 blah. So there is different skill. Well, there is more than that. Here I put just one for space, but you can define multiple skills, and so the client can decide what to delegate to this agent, again, using a natural language, and use it as an agent.
It seems very similar to like an open API description for an agent, right?
Yeah, right. That's the idea. I don't think I will go so deep using also those slides, but I can mention that, for example, all the security stuff, authentication, authorization, and so on, is using the Open API standard. So all the beer token, for example, is the one coming from Open API, and the same is for authentication, authorization, and so on. So we are trying in the specification to don't reinvent the wheel as much as possible, because in the end, A2A agents are just accidentally using AI. You can define an A2A agent even without an LLM, and the protocol still work. You can write a completely deterministic A2A agent, because the protocol takes care only of how to make them communicate and how to keep track of tasks. Let me see if I can find, yes, this one. The state machine used to keep track of tasks. So a task start on submitted and then working could fail, the red ones, or complete, the green one. But the most interesting are the yellow one, because it's input required and out required. Just ignore cancelled, that is a special state. Because the state machine of a task is important to understand, that is designed to be managed by an LLM. So at some point, the LLM could realize that need more input. And so instead of sending an answer to the client, is sending a request for a new input, and the client should be prepared to provide more input. And the same, the LLM could...
Can I jump in quickly when you have a chance?
Yes, sure.
Okay, so basically like the task is like the representation of like a long-running thing on the agent side. So the client sends messages which get added to the task. It might ask the LLM something from the message, and then the response goes into like something called the artifacts in the task. And then it also has these states, which Stefano was talking about.
Yeah. The other requirement that can happen is out required. So the task go so far that need a tool, for example, or another agent that require more authorization. So ask the client to provide a beer token, for example, to provide those authentication or authorization. That's the way, more or less, that the long-running task perform. And before move to Kabir, let me see if there is anything else that I can show you. No, I don't think so. The other important part to keep in mind is that implementing an agent in A2A is pretty simple. And as Kabir will show you, you basically need just to implement two classes, the server part at least, I mean. One is to provide the agent card, and the second one is called the executor, and is the business logic of the agent. And there comes all the AI stuff and so on. This is just to give a very general introduction on what is an agent versus a tool, and give some of the slang in A2A, and then I think that looking some code could help much more than my words.
Cool. Cool. Shall we flip to the demo?
It's not really a demo, it's like more
Oh.
code walkthrough, but
Okay.
let's stick to that.
Yeah, we'll flip to the code.
Right. So first I'll show you like kind of how the architecture of the server side of the SDK is layered. So the innermost layer is this default request handler. It's in the server common module, and I've just jumped to the wrong place. But anyway, it's got like methods like handle when a message comes from the user, then it does stuff and so on. You can like cancel tasks that are running on the server and things like this. So that's like the very core. Then there's a transport layer. Let's see if I find that. So we basically have three transport layers, or three different transports, I mean. So there's gRPC, JSON RPC, and REST, and these all kind of are mandated by the spec. So an agent doesn't necessarily have to provide all of them, but they can do one or all of them. So then in the transport layer, we have another handler. In this case, I'm just showing the JSON RPC transport. So this has like a message send method, and under the hood, this delegates to the default request handler we saw. So there's like one handler per transport. And this is really because like the payload, or how this reaches this part of the handler, it depends a bit on the transport. It's like slightly different payload. So this is all with the core SDK, and that's more or less it. It's worth pointing out there's like lots of reactive stuff going on. So we return like flow publishers and things like that. So as our implementation, we use Mutiny 0 from Small Ryan Quarkus to basically provide this like zero dependency implementation of the Java Flow APIs. Before I jump to how we integrate with Quarkus, I'll just mention the client really quickly. So that lives in the client module, and it has like methods to send message, cancel tasks, and so on. So it basically mirrors what we saw on the server. I was going to say something. Yeah, so basically like the client also again has several like the same transports as we saw. And this client can basically communicate with any A2A agent. It doesn't matter if it's written in Java, Python, .NET, or whatever. So going back to the server-layered architecture, we saw like we had the core request handler, the transport handler, and then we need to expose it via some framework. So in our case, we started off development on Quarkus, and that's become the reference implementation that we use to have something to run our tests and the TCK against. So basically, what the server integration needs to do is like deal with like peculiarities for your environment, and then expose to the web the endpoints that the client should interact with. So since we're using Quarkus for this, again, I'm showing the JSON RPC example. So here we basically used Quarkus reactive routes because that was kind of like the most modern way to to use Quarkus with this stuff. And we have the JSON RPC handler that we saw earlier, coming from the core SDK transport layer. And then we basically, when requests come in, then we somewhere up here basically delegate these method calls onto the SDK transport handler, which then delegates onto the default request handler, which is where all the real work happens. So this reference implementation is Quarkus specific. So since we're using Quarkus reactive routes, this will not work really in a Jakarta environment. So we have a Jakarta implementation in Wildfly Extras, which is tested with Wildfly. And people are also implementing support for Spring, and I think Google have their own integration layers and stuff like this. So doing the integration is just like writing this simple REST endpoint wrapper. So the key point really is that the SDK is agnostic about the platform, and you can basically adapt it quite easily to wherever you want to run it.
And then do all of these implementations then pass the TCK?
They should do, yes.
They should do, yeah.
Well, ours, the A2A Java one does, and the Wildfly one does. I don't know about the others, but I think at least the Python one should do.
Yeah, I think at the moment .NET 1 is passing 90% of the TCK. Python a bit less than that, because they have some assumption that to me is not super correct, but we are discussing on that if TCK is wrong or Python is wrong. But yeah, the idea is that all the implementation should pass. I wanted to remark that by design, how the A2A server side is designed, not all agents enable all capabilities. So the idea for the TCK in this case is even more wide impacting than standard TCK, because if you take any implementation of A2A and you implement your own agent, you want to verify that your agent is compliant with A2A. Also adding the right feature, and when adding the feature, you are handling in your executor the feature that you added. So the TCK is useful in this case not only for SDK implementers, but also for final implementers of agent. For this reason is pretty important. There is another project also in A2A area that is called the A2A Inspector, which is basically a less deep verification of the specification. So you basically can take a message, send a message to your agent that you implemented on top of any SDK, and see if the message is correct and the agent is answering correctly. But Inspector help you during the development phase. But if you need to fully verify that your agent is fully compliant to A2A, you need the TCK in the end.
On that note, it's worth pointing out that there's like some quite big changes unifying everything for the 1.0 version of the spec. So we will break the TCK and need to improve the TCK as part of that work.
Yeah, that brings us to an important topic for the audience, probably. The A2A specification is very young and very dynamic at the moment. With dynamic, I mean unstable.
Disclaimer, you're at your own risk.
No, a bit joking on that, but not too much. So basically, current specification released is 0.3, which has been considered the first stable enough to implement on top of it. But now we are working at 1.0, was called 0.4, and now we recalled it 1.0 because it's full of breaking changes. But that one should be much more stable in our idea, because, well, basically the specification has been largely refactored. Between 0.2 and 0.3, we added different transport layer. So until 0.2, we have only JSON RPC. After 0.2, we introduced the gRPC and REST, basically. What 1.0 is doing is basically to be agnostic for the transport layer. So we defined the logic of the transport, and you can plug any kind of transport. The supported ones will be the three already mentioned by the specification, but the customer or the final implementer can add a queue-based one or any other netty one or whatever they want. The new specification is designed to be very open to SPI for different transport, and it will make it much more stable. On the other hand, is a pretty new and dynamic, as said, specification. So we are not putting everything that is new into the specification directly, but there is the concept as a web service in the past had, just to mention one, of specification extensions. So the idea is that you have a very core stable of the specification with just task management and those three, transport and transport agnostic. And if you need to add something on top of that, for example, metadata or discovery mechanism or whatever, you can define a specification extension. The idea is to have a repository with all the extensions very soon, and which means the specification part and a referential implementation for each extensions. At the moment, there is a few extensions already around. One of the most famous is AP2 from Google, Agent Payment Protocol, that went on the news a few weeks ago, because they define a way to make a payable task that you delegate to agent. So the user sign a contract with a seller, and then is the agent that complete the contract when the conditions are the best for the user. This is an extension to A2A. The same, there is another one that is X402, that is for micropayment between agent, and again is an extension to A2A. And then there is another one for discovery mechanism from Cisco, and again is an extension to A2A. So it's step by step becoming an environment or a set of extensions that add the feature to the basic implementation of A2A, but always having a good standard behind and extending this standard. So it's pretty promising for the future. Probably not in terms of weeks or months, maybe years, but it seems pretty promising and pretty exciting.
Yeah, interesting. And that extension idea makes so much sense, because there's always sort of a trade-off, isn't there, between the innovation and the stability, and allowing that extension mechanism allows you to a little bit more get both.
Yeah, there is another one from IBM research, for example, to add metadata to the message exchange, because everything at the moment is on natural language, but there is cases, when you need metadata between agents. And so there is also this extension to make more formal the communication between two agents, but still around that. Sorry, Kabir, I interrupted you probably.
Yeah, we haven't got to how to write an application yet, so I'll show that quickly. So I'm just going to show from our TCK, in the TCK module. So there's a CDI bean, which basically produces an agent card. So, well, Stefano covered all of this really. It basically says what the agent can do and how it can do it. He mentioned you can turn some capabilities on and off when you want to pass a TCK. So this is where that happens. So for our TCK, we basically support streaming, push notifications, and everything else. And we've also configured it to use all the transports that exist in the spec. Then the next thing, so there's sort of summarized a bit. So you need to provide three things, like the agent card, which we just saw, the agent executor, and then set up the right dependencies. So the agent executor producer again produces an agent executor with CDI. It takes this thing called request context, which is created by the default request handler we saw. There'll be a task in there if it's not the first message that could potentially result in a task. And if there is no task, in this case, we create one and put it on the queue. And then we simply just update the state. So this is like a really dumb agent executor, which doesn't really do anything. If you're using an LLM or wanting to call other agents, then this is the class where you typically do this. Then the final bit of the puzzle is to basically include the proper dependencies for the transports and whatever serves it. So in this case, we're using the artifacts containing the referenced implementation for each of the three transports. I'll just mention one more thing, which might be interesting. So the agent executor basically is run in a separate thread from the request handler. And then it communicates back to the request handler or any other clients which have registered an interest in wanting updates to the task. So it does this by putting it on the event queue, and then the default request handler, by some quite complicated mechanisms, gets these events and then sends them back to the client. And basically that leads me to the next thing, which is the default implementations in the SDK of the stores that are used to store the tasks, and something called push notification configs, which we haven't looked at, as well as the queue manager managing these event queues. They're all like simple in-memory hash map type things. So if you like in Kubernetes with 5 pods serving the same agent, and your requests hit different pods, then it will break, of course. So what we have is some initial enterprise components. in this extras folder here. So we have a replacement for the push notification config store and the task store, both of which persist the task store push notification configs in a database with JPA. And then we also have a replicated queue manager, which has different implementations. Well, we only have one, but that uses basically reactive messaging, and then you can configure that to use Kafka or AMQP or whatever. So then if you configure this, then basically you'll survive server reboots. It doesn't matter which node your requests come into, they're all working on shared state. And there's actually a little quick start in here in the cloud deployment folder. So if you're interested, you could take a look at this and see a full setup working for a clustered environment. And although we just
Kabir, and
yeah,
maybe
sure.
maybe you're gonna get to this. So with all this like distributedness and things going all over the place, is this all tied into like open telemetry and tracing and metrics and all that fun stuff? So
we're working on open telemetry. And I guess metrics will come one day. I don't think it's on our roadmap, but I'll make a note and we'll put it there.
Yeah, more the observability stack, just so like the stuff will go wrong. You know how with non-deterministic systems, things don't always work right. So being able to watch and figure out what went wrong where, and that's
Yeah, because non-deterministic plus distributed.
Yeah, right. Just consider that as Kabir is showing here, showing an executor, all the logic and business logic is inside this class. So it is also up to the final user to add all the telemetry and observability stuff on what is going wrong. The AI part start only here. The indeterministic part start only here. All the rest is just communication protocol, which all is right, is distributed, so could be indeterministic too, but just consider that it is responsible to the user also to add observability.
Yeah.
So that would be like where Quarkus or Spring or something came in and added that on top.
Yeah.
Yeah, although I think Emmanuel has like a pull request to have it looked at for open telemetry. But I still need to look at it. I think like I've only got one more thing to say. It's like all these replacements to make it more enterprise. They basically just like implement the interface. So for example, here's the replacement push notification config stores. So it basically just implements the interface and creates another CDI bean with a higher priority to replace the in-memory one. And these interfaces are quite simple. So our intent isn't like support everything that the user might need, but to make it easy for them to integrate with whatever they like. So yeah, I think I'm done.
Yeah, something else probably to remark after we have seen all this code for Quarkus user, it may seem a lot of boilerplate code, and at the moment it is in the SDK because it's very general, but we are working closely with Quarkus team to try to have much less boilerplate code or no boilerplate code, doing everything through the standard Quarkus way with annotation, configuration, and things like that. So this is
like the agent card could probably be like some annotations.
Yeah, exactly.
With some defaults, and the execute could probably like have some methods annotated with something, and then basically just call those. That's the kind of wooliest part, I think.
Yeah, and something else that I wanted to remark is that LangChain4j agentic module that has been a part of another Quarkus Insider already, as also the client for A2A. So from one of your agent in LangChain4j agentic module, you can call a remote agent using A2A already. So this is only the client part. The server part needs to be coded at the moment, as we showed you, but we are working on the Quarkus side of things to make it much easier. I'd like to show another slide to explain an important aspect of A2A. If Kabir, are you done right with the code?
Yeah.
Okay. So this slide that I'm showing you is the example I used in that talk I mentioned. We don't have time now to run everything, and it's not particularly significant to see it running. But one of the aspects that is important having a protocol like this that is agnostic for framework, agnostic for language, is that you can create your application using different framework or different languages for each piece or each agent. And in this example was a content writer that write a Twitter post using 3 different agents. One for the planning of content, so it search on the internet for the contents and so on. And then there is another one that is writing the post, and another one that is the editor of the post. And those 3 agents are in 3 different agent, and one is written in Python using ADK from Google. The second one is written in Java, Quarkus plus LangChain4j, and the third one is written using JavaScript. And my example is showing that at some point, any point, you can just turn off the JavaScript one and start the same agent with the same capabilities and same skills written in Java plus LangChain4j, and everything still work because of the protocol that guarantee the working smoothly. And this is very important, because if you have an environment where maybe data scientists start prototyping using Python or whatever other language that is more usual for them and create this agent, but in the end, when you are ready for production, you want something more stable or more easy to maintain, like Java with Quarkus.
With observability.
With observability, for example, and so on. So you can just swap the agent. And yes, it's the same. Could be the same language maybe, but just a prototype written again in Java, but without observability. And then when everything on the non-deterministic part start somehow working and the evals are okay, and so on, you want to add all the stuff that make the agent an enterprise piece of software. And then you just swap it and that's it. So that's the reason, because of the title also of the insight that is breaking down the silos in AI. Okay.
Nice.
Yeah, good. There is quite a lot of blog posts, and one of them is showing exactly this example and how to run it. So you can follow the instruction on that blog post written from Farah, if I will remember. And so have fun and give it a try. And please join us. It's a vibrant, very vibrant community. We have a lot of contribution, different contribution from everywhere almost. Oktoberfest has been a great success with many contribution in the project. So you are more than welcome to contribute.
Said like a good open source maintainer, PR is welcome, right?
Yeah.
Issues too, but PRs are better.
Yeah.
PRs are much better.
Depending on the size of the PR.
Yeah.
Yeah, sometimes those really huge PRs are a bit of a double-edged gift.
Good choice of words.
So, any question?
Yeah, I'm just looking through the chat, and I don't think we've had any. So, what about from you, Eric? And I think we got our questions. We managed to interrupt Kabir and Stefano while they were talking. So
I always hate they're like in a train of thought, and it's like, but I don't want them to get past where I want the question. So do I interrupt or do I wait for them to finish? But you seem to like not take a breath, so I decided to interrupt.
Yeah, it was just for give time for questions, but now that we don't have questions. Okay.
Yeah, no, I think that's really sort of comprehensive walkthrough of where people can start using it and also start contributing it with those huge PRs.
Yeah, maybe I can just remark, and if you wanted to show the slide I just selected, that security is a first citizen here, and I want to remark it because it is one of the main concerns I heard about AI in general, MCP specifically, and so on. But security is a first citizen since the beginning. As I said before, built on open API and the web standards. So nothing new, because we don't need nothing new. We don't need anything new. Is everything okay? So there is APKE and HTTP bearer, classical JWT, and so on. OpenID Connect, and everything is HTTPS. Is a must in the specification. And the same for the server identity verification is a must through the TLS certificates. So just to remark that one of the main concerns I heard about agents is security. We care a lot about security, and not only in Java SDK is part of the protocol. So any agent in the protocol should be very carefully designed for security.
Yeah, because you always used to get the joke about IoT, didn't you? That the S in IoT was for security, and then you can just sort of extend that onto, the S in agents is for security. Although actually there is an S in agent, so that doesn't work at all. The S in agent is for security, but here we have the S in agents, which does have the security.
So it looks like there is a question that popped up here. Can you try it locally with Olama, for example?
Yes, nothing prevent you to do that. And well, in general, this is a very good question, because it comes to the idea of agents. Because agents, why breaking everything in many agents, like in the example that I showed before, this one? Why to break this when if you take a state-of-the-art model, you can just ask everything to it and it will do. But splitting the job in different agent could be useful also to use smaller model, maybe well-trained or fine-tuned to do a specific work. And so, yes, why not? Ollama is a good one to test it. You again, all the AI stuff happen in the executor. What happens in executor is up to you. So yes, you can use LangChain4j locally on Ollama.
Cool. Thank you. Any
Regarding those huge pull requests, Google set us up with Gemini code review, so it's a bit easier.
Yeah.
yeah.
So who's reviewing what Gemini is telling you?
Well, it picks out, it's quite good at picking out problems and getting an overview, but you still have to review it, but you kind of make it re-review until it's happy, and then you look.
Yeah, it's a bit less overwhelming to have to sort of just go right in. Yeah.
And it gives like a nice summary of what's going on and stuff as well.
Yeah. It's very good on that. Yeah.
Nice. So any last questions? No, I think we're good. So yeah, thank you again so much for coming and showing us this, Stefano and Kabir, and we will see everybody next week. See you all.
Thank you. Bye.
Thank you. Bye-bye.